Hello viewers, welcome to Add-on. In this question, we are asked to derive the minimal expression for the following function using K-map. And it is a three variable K-map because there are three variables which are given to us, f of x, y and z. So it is a function of three variables x, y, z, and these are the minterms which are given to us. So let us start with the solution. At first, we need to draw the K-map to solve this question. So as I have said earlier, this is a three variable K-map. So for three variable KMF, we will be getting 8 number of cells because, for example, let us consider a 3-bit number. So by 3-bit number, we can get a total of 8 combination like this, like 000. It is a 3-bit number. Similarly, we can write 001, 010, 011, up to we can write up to 111. So this will represent 0. This will represent 7. So there are a total number of 8 combinations. So similarly for our 3 variable K-map, we will be getting 8 number of cells. So let us draw the K-map. So this is the K-map. So there are 1, 2, 3, 4, 5, 6, 7, 8. 8 number of cells. Okay. So let us write the variables. So we are representing each of the rows by a variable of x. Okay. And the columns are represented by a variable of yz. Right. So x is a 1-bit variable and yz, these are individually the 1-bit variable. But if we combine them together, they become a 2-bit variable, right? Because x is a 1-bit variable, so it can assume the value of either 0 or 1. But yz, if we combine them together, they become a 2-bit variable. So they assume the value of 0, 0, 0, 1, 1, 0, 1, 1. And one thing we need to note that the cells, or we can say the rows number or the column number in the K-map, should be marked with gray code. We do not use binary code in this case. So for the first row, this will have a value of 0 and this will have a value of 1, and this is represented by the variable of x. And these columns are represented by the value of yz, and we will write it into gray code. So at first, let us find the gray code of this binary number. So for 00, so for 00, the gray code will be 0. So we will write the most significant bit, which will be the bit on the absolute left hand side at the first. So we will write 0, and after that we will just XOR get these two adjacent bits. So 0 XOR 0, which will be 0. Similarly for 0, 1, we will write the most significant bit as first, which will be the bit on the absolute left hand side. So this will be 0, and 0 XOR 1, which will be equal to 1. And for 1, 0, at first we will write 1. So, and 1 XOR 0, it will be equal to 0. And for 1, 1, at first we'll write the MSB, which will be 1, and 1 XOR 1, which will be equal to 0. I think in this case it will be 1, because the MSB is 1 and 1 XOR 0, it will be equal to 1. So these are the respective gray codes for our 4 binary numbers. So let us write the gray codes in sequential order. So for 00, we are getting gray code of 00. For 01, we are getting the gray code of 01. But for 10, we are getting a gray code of 11. And for 11, we are getting a gray code of 10. So each of the cell numbers, we can represent each of the cell number like this. So for a particular cell, we need to combine the value for a particular row and the value for a particular column. So for this cell, it has a row value of 0 and a column value of 00. So it will have an individual value of 0, 0, 0. This is for the first cell, right? Similarly for the second cell, it has a value of 0 and the row and column of 0, 1. So it will have a value of 0, 0, 1. So this will be equivalent to 0, this will be equivalent to 1, and likewise. Okay, so this will have a value of 0, this will have a value of 1, and this will have a value of 0, 1, 1. For 0, 1, 1, this is the cell number 3. This is the cell number 3. In the first row, this is the cell number 3 in the first row. So this will have a value of 3. So here this will have a value of 3. And for the fourth cell in the first row, it has a row value of 0 and a column value of 1, 0. So 0, 1, 0, it is the fourth cell in the first row. So it represent the value of 2. Okay, like 0, 1, 0, it represent the value of 2. And for the second row, this first cell have a value of 100. So this will be equivalent to 4. So this has a value of 4. For the next cell, it is 101. This will have a value of 5. This will have a value of 5. And for the next cell, it is 111. This will have a value of 7. Okay, because 111 is 7. And for the next cell, this is 110. So this will have a value of 6. So this will have a value of 6. And in this case, this is 2. So this will have a value of 2. So in this question, the min terms are given to us, which is 0, 1, 2, 4, 6. So in this 0, 1, 2, 4, 6, we will see these are the 0, 1, 2, 4, 6 in the K map. So in those position, we will write 1. And in the rest of the positions, we will write 0. So when we look at the questions, the min term which is specified to us, we will write 1 in those cells which are specifying those min terms. Like this cell is specifying the min term of 0. This cell is specifying the min term of 1. This cell is specifying the min term of 2. This cell is specifying min term of 4. This cell is specifying min term of 6. So we will write 1 in those cells. And and those cells which are left out, which are not given in our question, we will write 0 in those cells. Okay. So let us read all the K map. So our K map will be uh, so as I have said earlier, the cells which are representing these main terms, we will write 1 in the cells, and the cells which are left out, we will write 0 in the cells. So here we will get 1, 1, 0, 1, 1, 0, 0, 1. And these are the variable x, y, z. And these are the row values, and these are the column values. Now the next thing we will do is grouping. Now we have to make a group of 1, and we have to make sure that the group is in the order of 2 to the power n, where n is a positive integer. Okay, n is a positive integer. So n can be anywhere from 1 to 3 up to n. Okay, so if we put 1 in the place of n, so 2 to the power 1 will be 2, 2 to the power 2 will be 4. So we can make group of like 2, 4, 8, 16 like this. Okay. So from the K map, we have to see that if we can able to make a group of 2 ones or 4 ones or 8 ones like this. Okay. So if we look at this K map, we can see that this forms a group of 2, right? This forms a group of 2. Okay, and if we look at this portion, this portion, this portion, and this portion, if we look at this, we can make a group of this one, this one, this one, this one. So we can make a group of 4, and we have to make sure that no one is left out in the K map. So if there is a single one and we can't make a group of any group of any 2, 4, 8, 16, we can make a group of 2 to the power 0, which will be equal to 1. So we can also make a group, or we can say we can take a individual one. Okay, so here n can be also 0, 0, 1, 2, 3, anything. Okay, so n is not equal to any negative integer. It can be 0, 1, 2, 3 up to n. So in this question, in this problem, I have made group of 2 ones in this case, and I have made group of 4 ones by taking this group, and this group. Okay, and after making this group, I have seen that only the zeros are left out. No one is left out. So my criteria is complete, because I have said we have to make group of only ones. We have to left out the zeros, and we have to make sure that no zeros is included in our group. We have to make group of only one, and that group will be in the order of 2 to the power n, where n is not equal to any negative integer. It can be anywhere from 0, 1 to 3 up to anything. So we can take only one individual one, or make group of 2 ones, 3 ones, 4, make a group of 2 ones, 4 ones, 8 ones, 16 ones, like this. So in this question our criteria is complete. So the next thing we'll have to do is to is to make the Boolean expression for this group. So as you can see, in this particular group, it has a row value of 0, or we can say the variable x has a value of 0. It is fixed for this group. But the value of yz, it is 0 0 for the first one, and it is 0 1 for the second one. So we will take that value which is constant. In this case, the value of y is constant, which is 0. The value of z has changed from 0 to 1. So for this particular group, the value of x is constant, which is 0, and the value of y is constant, which is 0. The value of z is not constant, it changes from 0 to 1. So we will make the Boolean expression like this. If the value is 0 for any variable, we will write it as complement, because if the x variable, suppose it has a value of 0, so we will write it at x bar. But if it has a value of 1, we will write it at x only. So here for this particular group, the x has a fixed value of 0 and the y has a fixed value of 0, and we will discard z because its value is changing. So for that particular group, our Boolean expression will be x bar y bar. And next for this group we can see that the x value is not fixed. It is for this group, the x value is changing from 0 to 1. And if we check the yz value, the values of the variable of yz, here it is 0 0, here it is 1 0. So the value of y has changed from 0 to 1, but the value of z is constant, which is 0. So we will just write it. So as I have said earlier, if the value is 0, we will write it as complement. So here the value of z is 0, and the rest of the values of variables are changing. For x it is changing from 0 to 1, and for y it is also changing from 0 to 1. So we will write here the value of z, which is fixed at 0. So we will write it as z bar. So this will be our required answer, and this is the minimal expression for the function using K-map, which has a min-terms of 0 1 2 4 6. I guess the process is clear to everyone. Thank you.